So today we're going to look at the law of sines. There's a law of sines and a law of cosines. And we're going to take a little bit of a flashback to geometry here. So, oh, y'all sound so disappointed. Okay. And remember, hey, and I told y'all won't use this at all in Algebra 2, and you're going to think I'm lying when I say it's important. And how many of y'all were thinking that last year? Yeah, like we really needed that geometry stuff. Well, guess what? We're going to talk about some more of it today. Okay. So we've used trigonometric ratios in geometry and in here to solve right triangles, right? And that's really the only way that we've used it to solve triangles, the only kinds of triangles. It's obviously not the only thing we've done with them. But, so I pulled this up because this is the notes from when we started trig. Okay, like, I mean, this is this year's geometry notes, but it's basically the same thing that y'all would have done. You know, we first talked about SOHCAHTOA and all that stuff, and it was so new, and you're like, what the heck is all this craziness, right? But I had y'all write at the top, right triangles only, and then in parentheses for now, because I didn't want you trying to apply it to something that wasn't a right triangle, because it wasn't going to get you anywhere. Okay, but you can use it for triangles that aren't right triangles, and that's what we're going to look at today, is learn how to do that. So it says now we're going to use them to solve oblique triangles. Now, we had oblique pyramids and prisms and stuff too. Remember what oblique? Yeah, because where are your oblique muscles? Right here. They're the muscles that allow you to do this, right? So if you're not a right triangle, you're an oblique triangle. That's basically what's happening, okay? Just leaning a little bit. So this big triangle here, ABC, not a right triangle. I probably could have done a little bit better job to make it obvious that it wasn't, but it doesn't matter. This angle is not a right angle. But this one is. So we're going to put a little right angle in here. Okay. And so for this triangle, line segment BD would represent what part of the triangle? Oh, come on. It's like 6th grade. The height, thank you. Not every question's a hard question. It's the height. Okay, so we're going to label it H, right? Then we know that when you have the capital letters that represent the points are named the angles, then the side lengths can also be named with those same letters. It's just across from the angle. So here's capital A. Across from capital A is little a, and that's the side length. All right, because the small letters represent numbers, which are just used like variables. So this would be side C. This whole thing here would be, length would be B. Okay, we all good with that? So in this big triangle, that's not a right triangle. We have two other triangles. It cuts it into two triangles, which are what kind of triangles? Right triangles. Okay, so we know how to handle right triangles with trig right now. So what we're going to do is we're going to start by finding the sine of angle A and the sine of angle C. Okay. So we know that for a unit circle, that sine is going to be y over r. That doesn't really help me here. I don't have a y or an r. But as far as triangles are concerned, sine is what over what? Opposite over hypotenuse. Y'all remember SOHCAHTOA? Yes? Do we need it? Okay. I'm not so confident in that, so let's go back up here. I'm a little worried now. SOH, CAH, TOA. Okay? And I think through that every time I'm even thinking about the y and the r, so I don't get the x and the y and the r mixed up. I still think opposite hypotenuse, adjacent hypotenuse. That you need to know. You need to continue to know. Okay, I mean, it's something that's important. All right, so we are going to find the sine of A, which as far as I can only do that right now in this little right triangle because that's the only thing we know how to do. So here's angle A. Opposite is H over the hypotenuse, which is what? C. For angle C, okay, that's a capital C. It's a little harder to tell, especially with my handwriting with the letter C. But sine would be opposite, which is H, over the hypotenuse, which is A. Okay, good enough? All right, so what do both of those little equations have in common? H, right? So we're going to solve both of them for H. Is that pretty easy to do? Yes. So if I solve this for H, I get that H is equal to what? Yes, I'm going to put the letter first, and I'll tell you why in just a minute. But you can say the sine of A times C. There's really nothing wrong with that, but it's kind of like when you have your square roots. You always want them at the end, just so when you're writing stuff, it doesn't look like things are mixed up and there's no confusion about what you're really taking the sine of. We're not taking the sine of A times C. We're taking the sine of A and multiplying it by C. So it's a little safer to put it in the front. So C times the sine of A. And here H is equal to what? A sine of C. All right, so now we have two equations here and technically three variables. So what do we have? What's it called? A what of what? System of equations, right? And so I have a system of equations. Now I've solved them both for H. Can I do some substitution here? Okay, so wording is important too. Now this doesn't really have anything to do with the law of signs necessarily right here, and even some of the things I'm gonna make you do today is not a law of sign thing. It's more of a notation thing and you getting full credit on things and you being able to verbalize things correctly. Here's what we're not doing. We are not taking these two equations and setting them equal to each other. All right, because that would mean I take H equals C sine A equals H equals A sine C. Does that make sense? That's setting them equal to each other. What you're doing is you're substituting, right? Terminology is important, especially when you're having to write out and explain things. I'm going to since this equals H, I'm going to substitute this in for this H right there. Does that make sense to you? In your mind, you might be thinking I'm setting them equal to each other, but the them is really the little expressions. So I know you would solve it correctly, but again, we got to be able to say it right. So I'm going to take C times the sine of A and set that equal to A sine of C because I'm substituting. All right, we all good? Does it matter if your letters are capital or lowercase here? Absolutely, because they represent different things, right? Okay, so what I would like to do is we're going to take this and we're going to divide both sides by, well, I just want the signs, we're going to get fractions. I was debating on how to actually do this. Technically, you can divide through both by A times C, but that just seems a little bit weird. But if I divided both sides by C, what happens over here? This cancels out. If I divide both sides by little a, this one cancels out and I get it in the denominator, right? So if I do that, what I end up with is the sine of A equals the sine of C, but what goes in the denominator here? What goes in this denominator? A, and this one is C. Does that make sense without me doing all the work that makes it look confusing and difficult? Basically, I divided both sides by C. That makes it cancel out on the left, and that ends up in the denominator over here. Divided both sides by A makes this one cancel out and end up over here, okay? So you end up with these ratios. Sine of A over A equals sine of C over C. I don't even have to know H. So if you look at this triangle, if I take the height out of that triangle, I no longer have right triangles in there. But if I know three of these four things, then I can find the fourth one. Does that make sense to you? So we can use this, depending on what we know about a triangle. We also have a law of cosines if we don't know certain things. But because if I have two angles and a side, then I can use the law of sines here, or even two sides and an angle, but we'll look at that next week because things happen a little bit differently. So what do you think this would also equal? Because there's a third fraction that goes with it. Sine of B over B. Does that make sense? So at least the letters go with each other. Sometimes you will see it written with A over the sine of A, C over the sine of C, and that's fine because that's the same thing, right? As long as I flip the whole thing, it's the same. So, you could see it either way, and we're going to go with this one. So here's your law of sines. That's where it comes from and why. It is the sine of A, capital A, because that's an angle, over little a, which is the side length, equals sine B, which is an angle, over little b, which is a side, equals sine C, which is an angle, over little c, which is a side. Okay, easy enough? It's pretty easy. As far as equations go and relationships, that's really not that bad. Okay, so now this is going to make your skin crawl a little bit. Remember proving triangles congruent in geometry? Wasn't that amazing and fun? But those congruent triangles, and I told you, you're probably never going to have to go prove that two triangles are congruent anymore, but it does apply to things. It does help you understand, knowing those helps you figure out properties of quadrilaterals and other things, and also is why you get to use the law of sines. Okay, so there were 5 postulates or theorems that we used to prove triangles congruent. Anybody can give me one of them? What? What? SSA? That's the one you can't use. There's no ass in geometry, Katie, remember? We see where your mind's going. Angle, side angle. Okay, I'm just kidding. Okay, so angle, side angle. But we are going to talk about that one, and there's a reason why we're not going to talk about it today. That's when we talk about it on Tuesday. So angle, side angle is one of them. What's another one? Side, side, side. AAS. SAS. No, I'm sorry. I thought, no, it's right. I was thinking I was missing one, but I was thinking ASA wasn't up there. So I was like, why don't I have enough links? And then one more that doesn't match the rest of those. It was only for right triangles. It's when you get to use SSA, but you only get to use it for right triangles, so you have to name it something that goes with right triangles. There was something with an L. Yes, HL, hypotenuse leg. So the 4 with the S's and the A's in there, we're going to use the HL doesn't really apply here, but it was one of the 5 that we talked about. Today, what we are going to use, we're going to use 2 of them. We are going to use ASA and AAS. We'll look at the other 2 that aren't HL on Tuesday, okay? So it says, given a triangle with the measure of angle A equals 46 degrees and the measure of angle C equals 63 degrees and C equals 56 inches. Okay, so I'm just going to tell you right now, on your homework, like it really bothered me that I already had the copies and I couldn't fix it because I was able to type this up like I wanted. It doesn't say this. It just says A equals 46 degrees. And so I think it even says angle A. Sometimes it just says A. Can an angle equal anything? A picture can't equal anything. Like angles can be congruent, but they can't be equal. It's supposed to have a measure there. I just have to say that, so I feel okay giving you the homework. I'm just telling you, it's not, the notation's not right, and it drives me nuts. So it's the measure of the angle that's 46. And I know you know the difference, and even if I said nothing, you'd work the problem's fine, but I can't help it. All right, so it says sketch a picture and solve the triangle. Always draw the picture. And you've got tons of room, so it doesn't have to be super tiny. You want to draw it big enough to where you can actually label things. And you kind of know what it's supposed to look like because you have 2 of the angles, but it does not have to be drawn to scale. Honestly, the more equilateralish they usually look, the easier you can label it. Whatever, it's fine. Don't even try and do it to scale. And then ABC. Doesn't really matter where your letters are when you start it, but then that will determine where little a and little b and little c go. All right, so then I know the measure of angle A is 46 degrees, so I'm going to label that in there. Measure of angle C is 63 degrees. And little c is 56 inches, which means that's line segment AB because it's across from C, so this is 56 inches. So let's look at what we have and the reason that these ratios work. I have 2 angles and a side that's not included, right? I have this angle, and then this side. So which of the 4, or which of the 2 that we're using today, triangle congruence postulates or theorems, would this be applying? Angle, angle, side, right? And now we only have 1 triangle. It's not even like we're trying to prove 2 triangles congruent, but the way that we're using it is, if we have another triangle that has these same 2 angles and this same non-included side, then it has to be congruent, right? And because all triangles that exist that have these 2 angle measures and this non-included side length are all congruent to each other, I can apply this ratio and it'll work every single time. Okay, so that's how we're applying it, but we're not really proving triangles congruent. We're just using the fact that angle, angle, side is one of them. So it asks us which one, and there's my answer. Okay. So then I'm supposed to solve the triangle, so that means I'm looking for this angle measure, angle B. I'm looking for little a, and I'm looking for little b. Right. So here's one thing. Cody. Come on, Cody. Here's one of the things that I know drives y'all insane, but I'm going to make you do it anyway. When you go to find the angle B, is finding angle B a pretty easy thing? Okay, yes. But remember, we're training you for the AP test, and I realize some of y'all are seniors, so you won't take the AP test, but you still will take calculus or something most likely, or you may be taking another one. Process matters, okay? And just crazy scratch work, which in this case, you may not even have to show any work, and I understand that, but the reason this works, the way you do this, you don't just add these together and subtract from 180. What happens is these 3 angles have to add to give you 180. That is a postulate or theorem that allows you to do those things. So at the very least, you have to write the measure of angle B plus 46 plus 63 equals 180. Because here's the thing. You ever added wrong on something easy? Or subtracted wrong on something easy? Absolutely. Isn't that when you usually do it wrong? When it's easy and it's stupid and it's frustrating? You have just shown that you totally get how to find the angle, right? And if you do some stupid, arithmetic error at this point, you still might get some credit, because it's not that you don't know how to find the measure of the angle, it's that you don't know how to add and subtract. You know what I mean? And you know you do, but that's where the mistake is. So that right there, you don't have to show every single sad little step like you had to in Algebra 1. Even if you don't show anything past this, it's okay, all right? But at least do that, because that shows your process on everything you do. First step, zero work, you substitute it in. All right, so what's 46 and 63? What? 109, okay. I'm not sure that's what I heard from everybody, so I was like, what? Okay, and so again, I would probably write this down, because by the time I got that, I might forget what I'm supposed to subtract. But I get in here then that the measure of angle B is what? 71 degrees, okay? So when we are solving the triangle, that means we're finding all the things we don't know. And we knew 3 things, so there's still 3 things we need. 1 angle and 2 sides. Okay, everybody with me so far? Okay, so now I have to find A or B. It doesn't matter, but as far as my little fractions go, I pretty much have to use angle C, because it's the only one that I know everything about, right? So I know that the sine of angle C, which is 63 degrees, over the length of C, which is 56, has to equal, and then we'll start with A, because it comes first, so it doesn't really matter. The sine of A, which is 46 degrees, over little a. Should I be punching things in the calculator at this point? Cody? I'm going to make you stand up and do jumping jacks while you write down your notes. No, don't even touch on your calculator. And again, process. Even at this point, I know you know how to cross multiply, right? So we're going to cross multiply and then divide by this, yes? But you need to at least write that down. A equals, you cross multiply 56 times the sine of 46 and divide it by the sine of 63. Then you get to go type it in, okay? You have it, you should always get to the final answer exact form and then type it in the calculator. And when you do that, what do you have to make sure is going on with your calculator? Degree mode. Check the mode, because we wanted it in radian the other day, right? We want it in degree today. And then when you do this, what are we typing in? 56 times the sine of 46. What else do you have to be careful with? Parentheses. Yes, you absolutely have to close that one. And then divided by the sine of 63. And do you have to close this one? You don't have to, but it's not bad to get in the habit, so you actually close it when you need to. All right. And then hit enter, and there's your answer. And how many decimal places should your answer always be to? 3. So A is equal to 45.211 inches. And it has to be accurate to 3. Okay. Easy enough? We good? All right. So now I have to find B. Well, I have A. Could I use A and sine of A to find B? I could. It's really best if you don't have to use something you found, don't use it. Because first of all, I'd have to store it, which is not that big of a deal. But if you did do some ridiculous mistake there, you have no hope of getting the next one right. So I can use what they gave me, so I'm going to do that. It's a little safer. So the sine of 63 again, over 56 again, equals, now I'm looking for B. So I do have to use something I found, because I had to find the angle. Hopefully I could do that right? Sine of 71 over B. So that means that B is equal to, in exact form, 56 times the sine of 71 over the sine of 63. Okay, so go ahead and type that in. Get your answer. What do you get? Good. B is 59.426 inches. Any questions about that? No? We good? Okay. Okay, awesome. All right, so let's look at the next one. So same kind of situation that we're starting with, and we're going to draw a picture. Not really worrying about anything else here. So A is 50, C is 33.5, and B is 76. All right, so which postulator theorem allows me to know that every triangle like this is going to be congruent to it? Angle. That's two angles in the included side, right? The other one was two angles in the non-included side, so this one is angle side angle, because the side is included between the two angles. Okay. All right. So I'm looking for angle B. This is side C. This is side A. So why don't y'all go ahead and work through that one on your own. I'm going to work it up here. So just don't be copying mine down. Work it on your own, and then we can check each other in the end. Okay. Okay, so I want to answer a question. Do we have to show all these steps on the homework? Yes. I realize you may feel like you don't have to show any of the steps, but did you get to skip some steps already? Yes. I mean, we didn't do the steps that actually get you from here to here, because that's okay. But here's what you have here. This is the setup. That's important. First step, zero work, you substitute it in. This is you solving it. Okay, it's solved. It took one step. Be happy it only took one step. And then this is the actual answer after you plug it in. Those are the three key things that have to be in everything you do. Sometimes you need other steps. Like you could skip this step here. That's fine. But you need these two. Also, you are allowed to use a calculator. Well, you have to. You're required to use a calculator. You can't do it without it, right? So use it. Okay? Even with things like this, when you're subtracting, use it, because that's where y'all usually make your mistakes, right? Is subtracting things and doing something ridiculous. So use the calculator so you don't get something ridiculous wrong. Well, yeah, your homework doesn't have units, so you don't have to put units on it. It's okay. drives me nuts, but it's okay.